What's going on, guys? Welcome back. My name is Brandon, and today we've got a fun episode in store. There's going to be a lot of welding, a lot of fabrication. We're going to be TIG welding some aluminum. Should be a lot of fun. Stick around. Last year, I built this dirt bike for my wife. The issue I have is I actually put a charging system on this bike so that when the bike is running, the bike is charging a battery. The issue that I'm having is that the voltage regulator rectifier that I bought is not compatible with a lithium-ion battery. So rather than replace the voltage regulator rectifier, I actually built a battery box, and I'm gonna install that and mount it on the bike. I've got some scrap aluminum pieces here, and I've got a battery. And what I'm gonna be doing is making a box that contains this battery. It's just a sealed battery, and it'll allow the charging system to work properly with this. So we're going to build this box. We're going to cut up some of this scrap aluminum, make that aluminum fit this battery, and then we're going to mount that all together on the dirt bike. We're probably going to have to put some tabs and stuff. I'm not really sure, but this should be an interesting video. So one of the first things I'm going to do is I'm going to cut this down the center approximately to make it fit this battery in width. So that'll be the piece that we're going to end up cutting a section out of. And we'll do the same thing to this other half. Just like that. So here are two halves that we just cut and put them together like that, and you can see there's just a little bit of a gap there, not much. So what I'm going to do is just make this gap a little bit tighter, and I'm just going to shave off just the blade width off this right here. Then width-wise it'll fit a little bit tighter. Now I'm going to cut off these ears right here about halfway across. Like that. Mark the same thing here. I'll weld that there, grind that flush, and then we'll cut this off. So you'll have a seam here, a seam here, and a seam here. So I'll have 4 butt joints to weld up that I can grind flush, and you'll never know that it was welded. You won't see the seams on the corners. And here we are, guys. I've got everything kind of fit up pretty decent. I've just run a flap wheel over some of the edges just to deburr everything, make everything real good. And now we are ready to set up our welder and get this thing welded up. And for this, I'm going to be using my YesWelder CT2050. This is an incredible machine. It's a 7-in-1 multi-process welder, runs on 120, 240. This machine does everything except for MIG welding. It does AC TIG, DC TIG, and it does AC and DC pulse TIG. It does stick welding. It's got an onboard air compressor, so you can plasma cut with this. So you don't have to have an external air source to run your plasma cutter. So this is also a high frequency, non-contact, pilot arc plasma cutter. It goes up to 45 amps in that setting. And it also has provisions to be able to hook it up to your air compressor if you have one. And for the AC pulse feature, it also has what they call smart, or this is kind of like synergic feature. You select your weld position, you know, if you're vertical or overhead, and set your material thickness, and this will set your amperage and your voltage and everything else for you, so you don't have to set those parameters. So this is just a really great all-around machine, and right now you can pick this up for half off, which is like $1,000. This is a Kickstarter program, so I'm trying to share this with a lot of people. In full disclosure, the channel gets a little bump if you do buy this through the link, but I just think that this is an awesome deal, guys. I mean, for $1,000 to end up with a machine that does every single process except for MIG welding, that's just my opinion. You can get your feet wet. This is 1,000 times better than any machine that I ever started out with, and it has a 2-year warranty. Go check that out. I'll have links down below. I always try to push things to people that I think are really beneficial, and I think that this is just one of those machines that kind of has everything that you're probably going to need. You know, someday you may decide, well, geez, I really like TIG welding, or I really like this process, and then you can go out and buy a dedicated machine to do just that. But as far as this goes, you can pretty much throw this in the back of your truck or take this out to your workshop, and you have pretty much everything you need to do everything. You can cut and weld with it. You should always practice before you go on to your finished piece. So I just took some of the aluminum that was left over from this and just started patting some beads, putting down some welds here and there, trying different settings, seeing what I liked, just messing with the machine. I don't do a whole lot of aluminum, so I have to kind of like make adjustments, try it out, see how it works, and then kind of sneak up on it, adjust gas and do different things. Kind of settled on this setting right down here, which I finished this one out right here at 100 amps, and I was doing that at 100 hertz with about 28 CFH of gas. So surprisingly, I was doing that in manual mode. So I said, well, just for the heck of it, let me put it over to the smart feature and see where that put me. So my settings that I came up with put it within 5 amps of this machine. So I'm just going to go with what this machine said. This machine settled on 95 amps at 85 hertz. I put the weld position in the flat. So let me show you. Let me turn it on. Just briefly, I'm up here on AC TIG, and I'm plugged into 240 volt power. I've got my weld position set on flat. You could also set it for vertical or overhead. Watch when you change it, it's going to adjust the amperage though. So let's say that was a vertical weld. It's going to put it down to 93. If it's overhead, it's going to put it at 92. So on flat, it's at 95. I've set the material thickness for 1/8 inch. Now the smart feature only works with AC TIG. It doesn't work for the DC side of it. So let's toggle through and show you what the factory sets for those parameters. So a 1/2 second of pre-gas. Start current, it's going to start at 25 amps as soon as it initiates the arc. It's not going to ramp up, so it's just going to go to 95 amps, which is, that's the pre-selected amps it went with. It's got no downward slope. The stop amperage is going to stop out at 20 amps. 5 seconds of gas flow after the arc stops. AC balance around 30%. I didn't really mess with that. The weld looked pretty clean. If your welds look sooty, you can mess with this. Change this up or down. And then hertz, the standard settings on this are 85. So, and I'm not overly set with one thing over another. I don't do a whole lot of aluminum welding. Most all the welding I've ever done is on transformer-based machines, and those are at 60 hertz. Right around 28 CFH of pure argon gas. For my tungsten, I'm using a 3/32 laser tungsten, and I know a lot of guys will ball it. I have just sharpened it to a point, and it is kind of like automatically balled itself just from just patting beads and using it. This tungsten, what I really like, it seems to last a really long time. So yeah, that's my setup, guys. DC electrode negative. I'm plugged into my torch is plugged into the negative terminal of the machine, and earth or ground is plugged into the positive. My table is grounded to this. Now I'm just going to clean down all my parts with some acetone, and for filler rod I'm using 3/32 4043 wire. Real important when you're TIG welding, guys, that you get all your parts super clean. What I'm going to do, guys, is I'm going to go through and tack everything together. Just put some like quick tacks on it to get the shape that I want, and then we'll go back through and run our filler wire on it. We still got to make the bottom for the box as well. And I know recently that I talked to you guys about getting some reading glasses and putting them under your welding hood to see, and it helps a lot. It's a huge help for me. We're all tacked up, guys, but what I think I should do to keep this from bowing inwards is make the bottom panel. So here we are, guys, and now what I'm going to do is I'm going to put some holes in the bottom of it, 3 holes, so that if water gets inside this, it'll drain out, just like any other battery box, because I wouldn't want this to fill up with water. Then we can grind these welds down flush and make it look really good, tune it up, deburr the edges, and probably going to put some tabs on it to mount it too. So I'll just find center. So 4 3/4 is what, 2 3/8. And let's say we'll come in an inch off each end. I want to start getting this cleaned up, so I've got my belt sander just turned upside down on my welding table. I got it clamped down, and I'm just going to face off this, and then I'm just going to clean off all of these welds all the way around it. So I put on a little bit of a coarser wheel. It's taking way too long to take this down, so what I'll do is I'll take down the brunt of it with this coarse one. Then I'll go back and do a finer one so it'll have a nice brushed finish. I kind of got a little carried away, guys, and went over all of it with that belt sander. I kind of like it. So what I think I'm going to end up doing, guys, is I'm going to mount, I think, the battery like right here, that battery box. But what I'm going to have to do is cut these little ears off on each side so that I can get this battery box to fit up in there. So it'll fit between the frame rails, but it just won't fit between this little plastic piece, which is part of the seat. So what I'm going to do is I'm going to trim those little ears off each side and hopefully leave this piece on right here. So I'll trim this off, and then we'll see what we got to do to get that battery box to mount in there. But you can see how this is going to work as far as it being out of the way. It'll definitely have plenty of room. It's going to be tucked way up under like that. So there'll definitely be plenty of clearance. So what I'm going to do, guys, is I'm going to take this little tab right here, weld it to the side of the battery box, and then I can drill through this tab. So just kind of make it up as I go. I think the next step I'm going to do is tack that little tab onto there. I've got everything cleaned up with acetone, and I've just clamped this little tab, as you can see, to the bracket where we're going to be bolting it to. So now what I need to do is just get a couple quick tacks on this just to hold this in place so we know it's going to stay. Then I can take this battery box out, weld it up all the way around, get a nice good bead on it, and then we can say that this side is done. Then we'll have to figure out something for the other side. This is actually going to be considerably easier than I had initially thought. So you can see I've just drilled the hole all the way through just to speed you up so you didn't have to see me drill a hole. And it goes right through to this side. So I'm just going to put the bolt all the way through. There'll be a lock nut on that side to keep it from vibrating, so that'll take care of that. And then on this side, this is where the airbox bolts to the bike. I'm actually just going to run a long bolt, and I'll show you from the top here in a minute, all the way through and nut it on the outside. So literally it'll just bolt right up. There'll be a bolt over here and a bolt on that side, and that'll hold that in there real solid. Yep, this should work out pretty slick, guys. And so that things don't loosen up and back off over time, using locking nuts that has nylon in them so that they always stay tight. And here's another look, guys, at how I'm going to bolt on this side. So one of those little button head bolts is going to go right through. You can see how that goes right through the frame, and then we'll put a nut on the outside. There. That is super solid in there, guys. That's not going anywhere. Over here, I got the little nut right there. Now we can just slip our battery in. Just like that. How slick is that? Just going to bring you in real quick before I put the seat back on. So I've got it all wired up now and just connected, red to positive, black to negative, and then just connected them where it used to go to that battery right here. Now we just got to put the seat on and button this thing up, try it out. And here it is, guys, done, all fully assembled. And you can see it's way up under there, out of the way. The suspension completely will compress and bottom out before this hits, so this can never hit that tire, which is a good thing. So it's nice and up out of the way, not a problem. You can see the white in behind that, so it's still protected up under there. There's not going to be any water or dirt that gets up in there. Maybe I didn't fully explain why I ended up building that, but just for the backstory on this, this is the battery that was in it, in this fit. Right on top of that air box that's right about in here, just tucked up in there nice. But because it's lithium ion, it doesn't work, like I said, with that regulator rectifier, which is mounted right here. So rather than rewire this bike, I just decided I'd put just a general battery. It just makes it a lot easier. And that battery was only like $13. I'm not really sure what the composition of that battery is, but it's not lithium ion. And then I shouldn't have the problems that this little small battery. I've actually gone through two of these, because what happens is that the charging system actually overloads this battery and it charges them too much and then it burns them out. So I actually bought one. These aren't cheap, they're like 35 bucks for this little battery pack. So I bought one and that lasted about 2 weeks. Then I bought another one. That one lasted about 2 weeks. So, I'm about $70 deep in buying a couple batteries. So that's why I decided to build that battery box, just get a regular sealed battery that's made for a motorcycle, and yeah, we're all set now. And if you want to see how I made this bike fully street legal, head on over to my other channel. It's called Motivated 207. I'll have a link down below and up above. You can check it out. But for you guys just wondering, I'll show you how this works. It's pretty slick. So turning on this turns on the gauge cluster and it powers up all the running lights. So you can see how that's powered up. This right here is the headlights, and this is a LED light bar, super bright, super bright. This was a fun build, converting the horn just like any other bike. Blinkers. The blinkers are integrated into the hand guards. And you can see the blinkers back here. Sorry for the wind. And I'll show you about this. So if I press this button, that's a stopwatch. It's got all kinds of functions. Currently the battery has 12.6 or 12.5 volts in it. And you can see it's got 14.9 volts maximum. It's showing an average speed of 23 and a maximum speed of 35. So that was the trip that we took earlier. Then it shows the time. It's currently 12:42. It's got 413 miles on it. Let me start it up and I'll show you how that works. Like I said, this bike has its own charging system on it. So it should, when it starts up, show a greater value. It's just barely idling. There we go. It's catching. If I give it throttle right now, it won't. It's cold right now. So there we go. You can see it's got 13 volts. So the charging system is actually working on this right now. And you saw the maximum voltage from the other day. Let me give it a little throttle. Hopefully it won't die. Yeah, that's that. Hey, this is a fun build. If you guys are into motorcycles, guys, check it out. I think you'll probably like it. A lot of work. Picked it up for 400 bucks. It was pretty rough, but it's a lot of fun on the street. And it'll do like 50 miles an hour. And that's all there is to it, guys. I want to thank you for watching. Thank you guys for tuning in. If you're wondering about any of the tools that you see me using, I'll have links down below. As far as that welder goes, it's going to be running out here pretty soon. You've got an opportunity to pick that up for almost half off. That's an awesome machine. I've been using it a lot lately just so that I could try out all the features, find out if there's any issues or any problems, and I've had none so far. I've been trying to use all the processes that I can. So I think it's a great value for someone who's just starting out. You get a lot of equipment for not a lot of money. And if you use the link below, you'll save a little bit of money at checkout. I want to thank you guys for watching. Thank you guys for tuning in. New videos every Friday, so be sure to like, comment, and subscribe. Until next week, guys, I will see you then. Take care, stay safe, see ya. Like, comment, subscribe. Bye.